Hi, my name is Doug Curl, and I'm with the Kentucky Geological Survey, and the purpose of my talk is to introduce a new version of our Geologic Map Service, which we released in July of 2020. I'll give an overview of how and why we developed it over the past 15 years, describe the technology we use for this version, and then take a brief look at the features of the new application. So if you've used the older versions, then hopefully this will provide some new insight into the data behind it, how we developed it, and about these new changes. We tried to keep many of the same features and tools as the previous version, but this design is quite different. If you've never used this application, then hopefully this will provide a good introduction to this service, what it provides, and also about KGS data. So KGS is the Kentucky Geological Survey, and we trace our roots back to 1838, but we've been a part of the University of Kentucky since 1948 as a state-supported research center within the university. We're the primary source of geologic information about and for Kentucky. We conduct earth science research, and importantly, related to this map service, we provide unbiased information about geologic resources, environmental issues, and natural hazards affecting Kentucky. So if we back up a little bit, I'd like to back up a little bit and look at an overview of KGS data because I think it'll provide some context for what we provide in this service and why we developed it the way we did. So KGS doesn't just have geologic map data like you would think a geologic survey does, but we have many other data sets, including the Kentucky Groundwater Repository, we have oil and gas data, we have coal data, minerals information, geotechnical data from our work with the Department of Transportation, and then of course our geologic mapping and research project data. Our oil and gas data is probably our largest data set. We derive wells from the Kentucky Division of Oil and Gas, and then we're the official repository for over 770,000 oil and gas documents for users. We also have a lot of scan publications, and then scan water well and spring records. But our GIS data is, really the focus of this on this map service, and probably the crown jewel data set of our GIS data is our digital vectorized geologic quadrangles from the original 707 geologic quads. And I'll talk a lot more about those in a minute. But we also have surficial geologic map data, and then we have the location of these database records, including oil and gas wells, water wells, coal data, etc. Mostly this is point locations, but if we have a point location, they're in our database and they can be displayed in a GIS. We also have a copy of the statewide LIDAR point cloud data that we use for internal research, but we use a lot of the derivatives from that state LIDAR point cloud on our map services. And this is derived from this point cloud data was collected through the Kentucky From Above program administered by the Kentucky Division of Geographic Information, and they also have rich imagery and other DEM information. So one of our goals back in 1996, and it really picked up in 2001 with better technology, was to provide all of our data that we could online in an easy-to-use manner without cost to users, and that was really important. We didn't, first of all, the technology for charging users was hard to do. And then we also had the expertise and technology to provide web data and map services without having to charge for users. So that I think was a really great decision, and we've stuck with that since then. But in 2001, we started developing web access to KGS databases and GIS data, and also providing access to all these scanned documents, such as the oil and gas well documents, which helped us better fulfill our obligations for being the repository for oil and gas documents. But in 2004, we debuted our Geologic Map Service, which is really the focus of this talk, and I'll be talking about the development of that in the next, for the rest of the talk. But just below there is a listing of all of our types of services and types of data and information that we provide online. So the story of the Geologic Map Service really starts in about 1960 with a joint geologic mapping program with the USGS to produce detailed 1 to 24,000 geologic maps for the entire state. We successfully completed this in 1978, producing 707 individual geologic maps. It was an enormous program, and we ended up being one of the only states, the only state at that time to be mapped at that detail. There's a few others that have been mapped, I think, since then, but we still remain one of the larger states that's mapped at 1 to 24,000 detail. So in 1996, we started a program, again funded mostly with USGS funds, to convert these 707 paper maps into GIS data sets. We had the original Mylars for many of the quadrangles, and so we scanned them, registered, rectified them, and then with an army of digitizers, we digitized the features from these maps using ArcInfo and AMLs. We digitized polygons of geologic units, the lines of geologic contacts, the lines of faults, and then captured really any other features that were on this map, including fossil points, quarry locations, and mineral locations, etc. At the same time, we also made the decision to scan in the stratigraphic descriptions from the columns on the side of the geologic map, and we used OCR to import those into the KGS relational database and related those to not only the map units, but also their stratigraphy, and created a database of the stratigraphy that you would encounter in Kentucky. Thereby, you can query the geologic map, bring back information about the geologic unit, and query the database with that information and bring back the description from the original GQ. This provides really rich information for the Geologic Map Service, and it turned out to be a really great decision that, frankly, we didn't really know why we were doing at the time, but we knew it was important, and I'm just so glad we did it. So we completed the digitizing program in around 2006, and when that was done, we compiled the data into a seamless detailed geologic map data set for the entire state. Again, we have polygons of geologic units, lines of contacts and faults, and then structural contours, and then other features. So in 2004, even before the digital mapping was complete, we started working on getting the data out to the public. And we did sell CDs containing the GIS data for the individual quads in shapefile format. These are actually still available, but as downloads through our list of publications. You can get the shapefiles for any of the 707 quads. But we also wanted to provide this data more immediately in an online map application. And speaking at an Esri conference, I think everybody watching this talk probably understands the desire to do that. But in 2004, these types of applications were really just starting to take off. And we developed ours using the ArcIMS ActiveX connector because we had a lot of experience using developing an ASP. And so we could develop a customized map application, which worked really well. But if you're familiar with ArcIMS, it was a little slow on the refresh. And as people got used to things like Slippy Maps with, say, Google Maps, I think the user experience got more and more frustrating as it took time to refresh the map. But this worked really well. We were able to showcase our geologic map data, and once we completed the full state, we were able to put the entire state online and make it accessible just through this web viewer with no plugins and that sort of thing. So we also got feedback from users that they wanted to overlay other data on here, including oil and gas wells, water wells, and that sort of thing. So, and from our other data sets. And so we added those to the map service. And because it was a customized map service, we could try to do this in a manner that wasn't overwhelming with the layer list. But a lot of our users don't have GIS software. And so this was really the only way they could display and query and look at this data, especially within context of each other. So we stood that ArcIMS service up until 2010. And then in 2010, ArcIMS went away. And so we redeveloped the service completely and using the JavaScript API and importing our data and porting our data over into ArcGIS Server. So take advantage of the ArcGIS Server services with the JavaScript API. This produced a much better user experience with a faster Slippy map application. Still provided all those data sets and including the detailed geologic map, but it was just a better design, more, a faster, also faster and more stable map service. In 2013, we also developed a separate mobile version, which also used the JavaScript API, but it was really pared down in functionality. But as more and more, as mobile use started to step up, we really saw a need to develop that version. And so we stood this up until this past year in 2020 when we developed our new map application. But if we just take a look back at the stats over the years, we averaged 62,000 page views a year, but we really get a lot of fluctuation with oil and gas prices, which I plotted in the green. And so I really think our baseline is about 42,000 page views. And then mobile stats are a little washed out in this plot, but the users of the mobile client has increased about 30% since its release. So that tells me we really need to develop something with more functionality for mobile clients as you get more and more people using mobile devices to access web pages. They don't necessarily need to go to a whole new application. So the new Geologic Map Service we debuted in March of 2020, and then we redirected all of the map service in July of 2020. And the reason we redeveloped this was a lot of reasons. One was that mobile use. We wanted something that was responsive in design. And so we took advantage of the new JavaScript API and a new layout, and completely developed a more streamlined web application featuring a lot of the same layers that we had before, but just better, more streamlined and also responsive. We also wanted faster layers, and so we finally took advantage of cached layers. To do that before, we would have had to recode a lot of stuff, and so just redoing the complete application was really the best step for us. So the technology we use, we're still using ArcGIS Server, but version 10.6, but the big change is we cast our geologic map layers. And we also now have superficial geologic map layers where that work has been done. We don't have entire state coverage for superficial geologic mapping, detailed superficial geologic mapping, but we now have that in the web application. Of course, we have our Bedrock 1 to 24,000 map layers, but we have a total of 57 non-base map services in the application. And I know that probably blows a lot of minds, but being a customized web application, we can develop this hopefully so that it makes a better user experience, so you're not just inundated with layers on the map. Most of the data is from KGS, but we also take advantage of data from the Kentucky from Above program, including statewide LiDAR, hillshade, imagery, and then some other data sets. We use the JavaScript API still, but now we've migrated to the version 4.x. We're at 4.13, and we're using the calcite maps layout. So it's a much, frankly, prettier design and just much more streamlined. We still use ASP pages on the back end just to make small SQL queries where we need them, and we return that data in JSON or HTML to do things like identify and pull back those geologic descriptions that I talked about before, and I'll demonstrate that. So I'll just go through some of the features of the map service. We have a custom Bedrock geologic map legend. This is really important. I think for people who are used to using geologic maps, they want to see the units displayed in stratigraphic order from youngest at the top to oldest at the bottom with their proper names, and with their ages. And so we can do that by querying the database for the extent bringing that back for the units that are displayed. We also have a feature in here where you can double click on a map color and it'll actually query the map and display the centroid of those units just to give you a visual cue of where those are located, especially for smaller units, whereas the Caseyville formation, you just double click and it highlights them. The advantage of using this new JavaScript API was it has a lot of great widgets that we used to develop this, and one of them is the layer list. And so we have a custom layer list with grouped layers. We can group all those 57 layers and organize them so oil and gas are together, water are together, the geologic map layers are together. We can also provide links to metadata or the ArcGIS REST endpoint or a web page, provide transparency control, and also even just embed the legend right within the layer list. So that's a really nice experience where it doesn't make those 57 layers overwhelming to users. So one of the issues with having so many layers is that it makes it difficult for users to revisit the map service and recreate their favorite configurations. So we developed a custom bookmark tool which users simply click to preserve the layer configuration with an ID embedded in the URL that they can bookmark or recall. On the back end, the layers that are turned on are saved as a pipe delimited list in a database and assigned an ID for each unique configuration. When the ID is called via the URL, the service queries the database to return the layers and turn them on and off using JavaScript. We also use this functionality to save quick map layouts of layer configurations that we think users will want to use over and over again. So we have the layouts such as the petroleum map layout that turns off the geologic units, but turns on the oil and gas wells, faults, and structural contours. This is something that we developed based on feedback from repeat map users, and I think having a bookmark tool and quick layouts like this is essential as we've committed to having so many layers available for display. And then we developed a custom ID tool which identifies features just like any other ID tool, but when a user IDs a geologic unit, the tool uses the attributes of the unit in the quadrangle to query our database for its stratigraphic description. These are the descriptions from the original geologic maps that we scanned and OCR'd and imported into our relational database, providing rich content about the map geology beyond just the name and age. And it really validates our decision to scan those descriptions during the digitizing program. We also have a separate web application which allows users to query these descriptions, and the next step is really to roll this functionality into the map service. The ID tool also returns coordinates on every map click, including Kentucky coordinate systems, quadrangle, and county for the point that's clicked. The next few slides are just some screenshots to look at this map service. I really encourage you just to check it out and look at all the functionality. But this is the first look when you open the map service. It displays the detailed 1 to 24,000 geologic map with the faults turned on at the statewide extent. Because we cached the geologic map service, the user finally gets to view the detailed geology at statewide scale, which previously you could only do when zoomed in. And I think it provides a really pretty map to the user. The menu on the left is where you access most functionality, and here displaying the layer list with the quick map layouts, which utilize the bookmark function. The bookmark tool and the legend are available from this widget. So here we are zoomed in with the detailed geology symbolized by the dominant lithology. The layer list uses cascading menus, and here I've also turned on the oil and gas wells. And you ID a geologic unit as dominant lithology, it highlights the unit, and you can display the detailed geologic description from the KGS database. So here we have the siltstone and shale as it's symbolized from the Borden formation, and then that detailed description below. And here we've displayed the detailed geologic unit symbolized by unit name, and then also the faults in the Pine Mountain area of Kentucky. Here it's displayed with the statewide LiDAR hillshade as the base map, and it really pops the features and geology of this valley and ridge area. And I've double-clicked the colluvium, and it highlights with those points where the unit is found in this view. So there's a lot more data and features on this map service for you to explore, so please check it out and let me know if you have any questions, comments, concerns, or ideas, and that's my email there. So thank you.